Hello viewers and welcome to my channel Pratham Maliya. I hope you all are doing great. Today we will be taking a look at what will happen when we drop a lighter object like a tennis ball and a heavier object like a basketball at the same height and at the same time. Now I wanted to make a prediction along with me. Which one do you think will fall first? The lighter tennis ball or the heavier basketball, or both of them fall at the same time? I hope you all have made your prediction. It's time we drop them. Three, two, one. Now you may be having a million questions in your head. Why did they fall at the same time? Did the earth pull them with the same force? Did they fall at the same speed? And what has all that got to do with resistance? It's time we find out. In order to go into detail so as to why they both fell at the same time, we must cover some important terms in kinematics. So, are you ready? In kinematics, or in rather any field, we have two types of terms. One is scalar and the second is a vector quantity. Now, a scalar quantity is a quantity that is characterized to have only a magnitude attached to its unit. That is, it has only a value along with its unit, like time. If somebody asks you the time, you would say the time is 8:45 and there's no direction attached to it. So that's a scalar quantity. Now for a vector quantity. A vector quantity is a quantity that has a direction along with its magnitude. That is, you have to specify the direction along with its value. Like, if somebody asks you, where are you off to? You can say that I am off to the supermarket that's half a mile from here. So you're telling the direction that is towards the supermarket and the distance you're going to travel. It need not necessarily be like a supermarket or towards your home. It can mostly be a north, south, east, or west. Now, let's come to the scalars of kinematics. There are three terms in the scalars of kinematics, that is speed, distance, and time. Now, you all know what time is, so let's move on to distance. So, distance is defined as the length of the actual path traveled by your body. So, for example, here's your house and you move to your supermarket. They are 30 kilometers apart and you come back from the supermarket to your house. So the distance you travel will be 30 plus 30 is equal to 60 kilometers. Now let's move over to speed. Speed is defined as the quotient of the distance covered by the time, which means that the distance covered in unit time. For example, you go from your house to your supermarket 30 kilometers away and take 2 hours for it. So your speed will be 30 by 2, that is 15 kilometers per hour. There are many important terms in the vectors of kinematics, but today I will list out only 7 that are the most relevant and important for today's video. One of the most important one is time. Since we already know time, let's move over to displacement. So displacement is defined as the shortest distance between the initial and the final point of a moving body, which means you don't take into account the length of the actual path. That is the difference between distance and displacement. Furthermore, there is a difference of the direction mentioned. In displacement, since it's a vector quantity, you will have to mention the direction, unlike distance, which is a scalar quantity. Coming to another important term, velocity. Now, when you're mentioning speed, you don't find the value enough, right? When you say 35 kilometers, it doesn't complete your information. So, you need to specify the direction of the moving body. And that's exactly what velocity is. You mention the speed of the body and its direction. So, if a body is moving towards north at 35 kilometers per hour, you will say 35 kilometers per hour towards north. That is velocity. But if you say 35 kilometers per hour, that becomes speed. Coming to two other important terms, uniform velocity and non-uniform velocity. Uniform velocity is when a body covers equal distances in equal intervals of time in the same direction, which means it does not change its direction and the intervals of time can be very small. This can also be called as uniform motion. Non-uniform velocity or variable velocity means when a body covers unequal distances in equal intervals of time in the same direction, or it covers equal distances in equal intervals of time but the direction changes. This is also called non-uniform motion. The next important term of vectors of kinematics in our list is acceleration. So acceleration is a rate of change of velocity or the increase in velocity in unit time. It is measured in meters per second square, means meters per second per second. Last but not the least important term in our list is acceleration due to gravity. Needless to say, it's a rate of change of velocity caused due to gravity. The acceleration due to gravity on Earth is 9.8 meter per second square, or for the sake of convenience regarded as 10 meter per second square. It is also called as small g, while big G, its elder brother, is a gravitational constant. Now here is our question. Why did the lighter object and the heavier object fall towards the earth at the same time? It is because the acceleration due to gravity is same throughout the earth. So it means that the heavier object or the lighter object fall towards the earth at the same time when dropped in the same height above the earth and at the same time. Why does this happen? Why does the heavier object and the lighter object accelerate towards the ground at the same time? It is because of inertia. Inertia is a resistance offered by any physical object which has mass in it to any change in its velocity. This includes changes to the object's speed, direction, and motion. Any aspect of this property is a tendency that objects to keep moving in a straight line at constant speed when no forces act on them. This means that when an object which has a lot of mass in it is once set into motion, it is very hard to fasten its speed or it's very hard to slow down its speed. That is the reason why the earth needed very less force to pull down the tennis ball, but much more force to pull down the basketball, such that they both fell at the same time. Because the basketball having more mass has more inertia, while the tennis ball having less mass has less inertia. This is what Newtonian physics says. That is, when a body is freely falling, it has only one force acting on it, that is gravity. But Einstein's general theory of relativity states that there is no gravity. Now you see why the resistance of an object is related to its speed. And if you have any other experiment that is unanswered for you and you want me to demonstrate for you, please put them down in the comments below. And if you like the experiment and the video, then please give my video a thumbs up. And if you want to play tricks with your friends by asking them the same question, then share it to your friends. I look forward to seeing you in another episode with another experiment. Until then, goodbye.